Hello, so today we are talking about probability rules, and specifically we're looking at some tables with those rules. So this goes with section 5.2 in your textbook. Please reference that section. Go look at other examples, look at other diagrams that it gives you because your textbook is a fabulous resource. So we're going to review key point number 1. We did this last video. We're going to do it again. This key point is so important. This is the definition of probability. Probability of any random phenomenon is the proportion of times the outcome, or what we're looking at, would occur in a very long series of repetitions. And this goes back to law of large numbers, which is super important. That is a key point. So if you don't have this in your notes from the other day, write it down now, and let's make sure that we always reference that idea that probability is the proportion in a long series of repetitions. So how do we model probabilities? We've talked about simulations last video, but those were kind of long and tedious, and we've other ways that we can model probabilities, but we do use simulations sometimes. So we can model probabilities to illustrate probabilities and outcome of events. How we do this is by creating a sample space. So a sample space we notate as S, and it's the set of all possible outcomes. So how we create one, for example, tossing a coin, the sample space is these little funky brackets, and inside the funky brackets, we write the two possible outcomes, or two or more, however many there are. So for example, tossing a coin, the outcomes are heads or tails. So those are the two events in my sample space. If we did this example, rolling a die, well, the outcomes would be 1, 2, 3, 4, 5, or 6. So I'd do little funky brackets, and I would say 1, 2, 3, 4, 5, and 6. So more often than having to create this, you will be given this and asked to explain it or evaluate one number in it and say what that number means. Another example, tossing a coin and rolling a die. Well, now if I have two events, my outcomes would be getting a heads on the tails and a 1 on my die, or tails on my coin and a 1 on my die, or heads and a 2, tails and a 2, heads and a 3, tails and a 3, so on and so forth. So how I write that is my little funky brackets. Well, I could get a heads and a 1, or I could get a heads and a 2, heads and a 3, heads and a 4. So we write these outcomes in my sample space, and we just separate them by commas. So I would keep going. Tails and a 6, and there we go. So there's a total of 12 events in that sample space, and an event is just one of the outcomes. So in this sample space of tossing a coin and rolling a die, there were 12 different outcomes, and we call those outcomes an event. So we use these events and we use our sample space in accordance with some probability rules. So the first rule is a probability is a number between 0 and 1. So all of my probabilities have to be less than or equal to 1 and greater than or equal to 0. So think it has to be between 0% and 100% chance of happening. So you see this notation right here, this P parentheses A, that stands for the probability of event A happening. So the probability of A, we just notate as P parentheses A parentheses. So this is my first rule. All my probabilities are between 0% and 100%, or between 0 and 1. The second rule is the sum of all the possible outcomes has to equal 1. So think everything has to add up to 100% in my sample space. If I look down here at this example, it says the age group, and it gives me 4 different age groups, and it says the probability of having Instagram. So what's the probability that 18 to 23-year-olds have Instagram, 24 to 29-year-olds, 30 to 39, and 40 and over? So if we add up all these numbers, we see that they add to 1. So that's a little check mark. And they're all in between 0 and 1. So they're always going to be some proportion between 0 and 1, and they'll always add to 1 in your table. So key point number 2, probabilities are always between 0 and 1, and the sample space must add to 1. The third rule is when I can start adding probabilities together. So we said events are disjoint if they have no outcomes in common. That means they can never occur at the same time. We also call this mutually exclusive. So you've probably heard of mutually exclusive in other contexts. Mutually exclusive means that they have no outcomes in common. They're not dependent on one another. There's nothing in common between the two. So if I want to know the probability of A or B happening, I would take the probability of A and add together the probability of B. So for example, if I wanted to know the probability of someone being 18 to 23 or being 24 to 29 and having Instagram, I would add together 0.57 with 0.17, which would give me 0.74. The complement of any event is the event that A does not occur, which we write as A with a little exponent of a C. So the complement just means it doesn't happen. You can think back to geometry when we had complementary angles. The probability of the complement is 1 minus the probability of the actual event. So we have 3 examples down here we're going to look through. The first one is done for us. It says if the probability of getting an ace, think back to deck of cards, there's 4 aces in a deck of 52. So if the probability of getting an ace is 4 out of 52, or 0.08, which is 8%, then the probability of not getting an ace would be 48 out of 52, or 1 minus 0.08, or 92%. So these events, getting an ace and not getting an ace, have to add to 1, which is why I can do 1 minus the probability of getting an ace. If we look at the second example, it says if the probability of winning a New Haven lottery is 0.02, what is the probability you do not win? So the probability of the complement of winning is 1 minus the probability of winning, which is 0.98 or 98%. Example 3, if the probability of rolling an odd number on a die is 3 out of 6, so the odd numbers would be a 1, 3, or a 5. I had a 2 there, but it's a 1, 3, or 5. What is the probability you do not roll an odd number? So I would write that the probability of the complement of an odd, or odd complement, would be 1 minus 3 over 6, which actually would give me 3 over 6, or 50%, because if we think about the options that are not odd, that would be a 2, 4, or a 6. So sometimes the complements are going to be the same likelihood as the event itself, but to find the complement, we just do 1 minus the probability of the event. So key point number 3, the probability of an event not happening is 1 minus the probability of the event happening. So this goes back to the normal curve. We think about everything has to add up to 1. Everything has to add up to 1 in probabilities. And we made that connection that the probability is the same thing as the area under the curve. So we're going to go through this example together just so we have one more awesome example in our notes. It says, suppose you choose a U.S. resident over the age of 25. The table below is a probability model for the education level the selected person has attained. And it tells us that the data came from a survey from 2006 to 2008. So make sure you get this table down in your notes because you want to have one of these examples to go back to. So part A says, what is the probability that a randomly selected person has a graduate or professional degree? Well, if I look, that's the bottom row of my table, and the probability is blank. It's not there. Well, if we think about our probability rules, there's one rule that can help us find that answer. If we think back, all of the probabilities have to add to 1. So if I add these first 4 up, I'm at 0.9. Well, to make it add to 1, the probability that the person has a graduate, we'll notate that as G. The probability of G is 0.10 or 10%. When I add up the others, they add up to 0.9, which means this one has to be 0.1 or 10%. So that's using one of my probability rules. Part B says, what is the probability that a randomly selected person has at least a high school diploma? Well, if I think about at least a high school diploma, that would be everything below the no high school diploma. So at least means at or above. So when I add those up, the probability would be 0.8 or 80%. So that's using my second rule, adding together different events. The last rule was the complement rule, and part C says, what is the complement of having some college? Well, the complement is everything except for that category. So I'm going to erase my table so I can see the numbers a little more clearly. The probability of the complement of having some college would be adding together the bachelor's and graduate with the no high school and the high school. So when I add those together, the probability of some college complement, or that little C up there, would be 1 minus 0.29, which gives me 0.71. And I could find that by doing the complement rule or by adding together everything except for some college. So this is an example of using my probability rule